Assalamualaikum and very good morning. Lecture 3, Unit of Concentration. So this is the outline of our lectures today. In the previous lecture, we have learned how to express concentrations of the solution. What is concentration? When we talk about concentration, it indicates how much solute it contains in a certain amount of solution. So we express the concentration in several ways. So for standard solution used in stoichiometry, either molarity or normality is used. This table gives us the definition for each concentration term used in analytical chemistry. Molarity, this is a common use in the lab. You should know that the volume of solution should be in liter rather than ml. Okay, for the mole, when you measure the solute in mole. For molarity, you have to know the mass of the solvent by dividing the mole of solute divide by mass of the solvent in kilogram. For part by mass, normally, for example, you use gram per gram. Gram of solute divide by gram of solution. And then for the part by volume, you use ml, for example, per ml. That's mean volume of solute should be used in the same unit as the volume of the solution. And then for the mole fraction, mole of solute divide by the total mole of solute and mole of the solvent. Okay, first, molarity. Molarity is the most widely used unit of concentrations in the laboratory. What is molarity? We can define molarity as the number of mole of species that contain in 1 liter of solution. Okay, bear in mind that this is not 1 liter of solvent. This is a common error made by student. So what is the difference between millimolar and molar? So when we talk about millimolar, it's referring to the millimole of solute per milliliter of solution. We use this millimolar as unit of concentration when we deal with small amount of solution, particularly in potentiometric titration. When we talk about molarity, there are two types of molarity, which is analytical molarity and equivalent molarity. Analytical molarity is the total number of mole of solute regardless of its chemical state in 1 liter of solution. That means when we calculate the analytical molarity, we just focus on the how to prepare the solution in the lab. This is preparations of solution. So an analytical concentrations of 1 molar of sulfuric acid just can be prepared by dissolving 1.0 mole or 98 gram of sulfuric acid in 1 liter of water, dilute to the exact 1 liter using a volumetric flask 1 liter. Just that's it. Okay, so what is the difference between analytical molarity and equivalent molarity? Equivalent molarity. Equivalent molarity expresses the molar concentration of a particular species in a solution at equilibrium. So if let's say we have 1 molar sulfuric acid, when we dissolve in water, actually it entirely dissociated into a mixture of 3 species as shown below, which is proton, sulfate, and also hydrogen sulfate. Okay, so the concentration of sulfuric acid is equal to 0. Important to say that we have to state the species molarity, it is necessary to know how the solute behave when it is dissolved in the solvent. Molarity and formality. When we talk formality and molarity, actually both unit express the number of mole of solute in 1 liter of solution. The difference between these is just when we talk about the equilibrium molarity, because equilibrium molarity is referring to the species concentration at equilibrium, and the symbol we use is a bracket. For analytical molarity is the same as the formality. It depends on the concentration of species that you want to determine. In this case, I take one example, sugar and salt. Sugar can be glucose, salt can be sodium chloride. Okay, when you dissolve these two substances in water, sugar, you take some two beaker and then put it water in both beaker, and in one beaker you add in sugar and another beaker you add in salt. When you stir and all this sugar and salt dissolve, you can see that both solution contain sugar and salt water. Right. But the difference between these two substances, sugar, when it dissolves in water, it will not dissociate. But for salt, when it dissolves in water, it will dissociate to sodium ion and chloride ion, for example. Okay, so this is how you differentiate the molarity and formality of these two substances. To make it clearer here, okay, in this example, we choose glucose. When you dissolve this glucose in water, the molar concentrations of this glucose and the formality of this glucose is the same, because this glucose is not dissolved in water without dissociate into ion. Okay, but for the sodium chloride, when you dissolve it in water, it will dissociate, right? It will dissociate to the sodium ion and also chloride ion. So the molarity and formality of this salt ion actually is different. This slide shows how to prepare a standard solution from the solid reagent. First of all, you have to weigh this solid reagent, high purity, analytical grade, for example, using the weighing bottle, weighing board here, and then transfer quantitatively into this volumetric flask at this volume, because perhaps you want to prepare at 500 ml solution, then you need to use a volumetric flask on 500 ml. You add in water up to this level, half of it, and then you shake until all this solid completely dissolve in this water. After it completely dissolved, then you add in water up to the mark. By using dropper, you add in to this meniscus. In order to speed up the process of dissolving this solution, you can use sonicator, or you can use a magnetic stirrer and magnetic bar to speed up the process of dissolution. And then you can calculate by using this formula. M referring to the molarity, N number of solute divided by volume of solution in liter. In order to calculate the mole, you need to know the mass of solute divided by molecular weight of. Okay, this slide as a revision, only for the revision. I just want to highlight how you differentiate between ferric, ferrous, cuprous, cupric. When you have more than one oxidation number for this element, we should know how to use the common name. When we talk about ferrous, it's referring to iron 2. Ferric is referring to iron 3. For copper, there is copper 1 and copper 2. So the lower oxidation number will be the copper 1. So cuprous actually is referring to copper 1, whereas cupric is referring to the copper 2. Okay? So you can also use a copper 2 rather than cupric sulfate, and copper 1 as a cuprous sulfate. In this exercise, you are required to calculate the amount of cadmium nitrate that required to prepare a solution of 0.1 molar cadmium nitrate by using a volumetric plus 250 ml in order to get 250 ml solution. So when you try, you can compare the result get with the answer given here, which is 5.91 gram cadmium nitrate, the unit required to weigh using weighing bottle, and then volumetric plus 250 ml. So what apparatus that you need to prepare this solution? Of course, you need 250 ml volumetric flask. You need distilled water. You need glass funnel. You need weighing bottle, analytical balance, and also a dropper. For this work, you can try yourself, because this is just this slide gives us the summarize for the formality or analytical molarity as the total number of mole of solute in 1 liter of solution. So this unit of concentration, molarity or analytical molarity, describe how to make a solution and not what exists at equilibrium. For mole concentration, for analytical concentration, whereas molar concentration, the species concentration that you want to detect. Next, we are going to discuss about the normality. Normality is an old unit of concentration. You can find it in this book, Standard Method for Examination of Water and Wastewater. In this book, there are lots of procedure. Some of the procedure may use this normality unit as a concentration for that particular solution. Next is normality. When referring to the old book, that you can refer to this page, or you can refer to chapter 5 for the new textbooks have been shared in the spectrum. For normality, when you want to use this unit, you should know what is chemical equivalent. What is chemical equivalent? Chemical equivalent is the amount of one chemical species that react stoichiometrically with another chemical species. So in this case, you should know an equivalent and also normality as a function of the chemical reaction in which a species participate. Although a solution of sulfuric acid has a fixed molarity, its normality depends on how it reacts. Okay? It's not the same. The parameter of N, which is representing the number of equivalent, is based on a reaction unit, which is a part of the chemical species involved in a reaction. In this case, you can have a look at the reaction between lead 2+ and iodide, which can give us a precipitation of lead iodide. In this reaction, the reaction unit is the charge of the cation or anion involved in this reaction. So the charge for lead is 2+, whereas the charge of the iodide is -1. So the number of equivalent for the lead is equal to 2, whereas the number of equivalent for the iodide species is equal to 1. When referring to other reaction, in this case redox reaction, the reacting unit is the number of electron released or accepted by the reducing or oxidizing agent. So in this case, you can have a look here. This is tin, which will be oxidized to tin 4+, whereas for the iron 3 will be reduced to iron 2. So for the iron, is involved only 1 electron, okay, which is released from this ion. Whereas for the tin is involved 2 electron accepted by the oxidizing agent. So in this case, N number of equivalent for iron is equal to 1, whereas number of the equivalent for the stannum or tin ion is equal to 2 by referring to the 2 electron accepted by this oxidizing agent. Clearly, determining of the equivalent number for the chemical species require an understanding on how it. When we talk about normality, you should know about equivalent point. What is equivalent point? The equivalent point is defined as the ratio of the chemical species formula weight to the number of its equivalent. So this is the definition. So when I ask you about definition of equivalent number, you can say in words as a ratio of the chemical species formula weight to the number of its equivalent, or you can give this formula. The simple relationship between normality and molarity is that normality, you should know the number of equivalent for that particular species, multiply the molar concentration. So for this part, you try yourself, and then if you have time, will be discussed later in the next class. Basically, normality is presented by capital N. It is the number of equivalent, which is EQ of a solute in 1 liter of solution. So this is the symbol that can be used for the normality. And normality must be specified with respect to a definite reaction. For example, for acid-base reaction, 1 equivalent is equal to 1 mole of proton or hydroxide donated. For the redox reaction, it's referring to the mole of electron transferred. 1 EQ is equal to 1 mole of electron transferred or accepted. For determining electrolyte concentration, 1 EQ is referred to 1 mole of the charge. And then how we are going to convert molarity to normality. To convert unit in formality to normality, then you should know number of proton or hydroxide neutralized for acid-base titration, or you can times number of electrons transfer. Basically, this is for the redox. In this slide, we are going to learn how to convert normality to molarity. By looking at this unit, normal, and then the value 0.2. What does it mean? 0.200 normal sodium carbonate. Before we start calculating, you should know what is the reaction involved for this species. This is acid-base titration. So the carbonate has 2 charge minus here. That means the number of equivalent is equal to 2. So 1 mole is equal to 2 equivalent number. If we have 0.2 normal it means that it contains 0.2 equivalent of this species in 1 liter. So how to convert 0.2 equivalent to mole? So by using 1 mole equal to 2 number of equivalent, so you have 0.2 equivalent, so equal to 0.1 mole. Because of the solution is in 1 liter, so the concentration in the molarity is equal to 0.1 molar of sodium carbonate. Okay, that's all for